That's not good enough. Good evening. Are y'all ready to start Vacation Bible School? Yes. You know what? This week, we are going to sing some of my favorite Vacation Bible School songs. And I tell you, some of these Vacation Bible School songs I was singing when I was your age. Are you ready? The first song, one of my favorite, Roll the Gospel. Roll the gospel chariot along. Roll the gospel chariot along. Roll the gospel chariot along, and we won't drag along behind. If a sinner's in a way, we will stop and pick him up. If the sinner's in the way, we will stop and pick him up. If the sinner's in the way, we will stop and pick him up, and we don't drag along behind. If a brother's in the way, we will stop and pick him up. If a brother's in the way, we will stop and pick him up. If a brother's in the way, we will stop and pick him up, and we won't drag along behind. If a sister's in the way, we will stop and pick her up. If a sister's in the way, we will stop and pick her up. If a sister's in the way, we will stop and pick her up, and we won't drag along behind. If Dick Blackford's in the way, we will stop and pick him up. If Dick Blackford's in the way, we will stop and pick him up. If Dick Blackford's in the way, we will stop and pick him up, and we won't drag along behind. If a sinner's in the way, we will roll right over him. If a sinner's in the way, we will... If the devil's in the way, we will roll right over him, and we won't drag along behind. So we'll roll the gospel chariot along. Roll the gospel chariot along. Roll the gospel chariot along, and we won't drag along behind. I think I need some cue cards, don't I? All right. The next song we're going to sing is I Don't Want to Be a Goat. Who wants to be a goat? No, we don't want to be a goat. I don't want to be a goat. Nope. I don't want to be a goat. Nope. 'Cause goats have no hope. Nope. I don't want to be a goat. Nope. I don't want to be a Pharisee. I don't want to be a Pharisee. 'Cause Pharisees aren't fair, you see. I don't want to be a Pharisee. I don't want to be a Sadducee. I don't want to be a Sadducee. 'Cause Sadducees are sad, you see. I don't want to be a Sadducee. I just want to be a sheep, yeah. I just want to be a sheep, yeah. From my head down to my feet, yeah. I just want to be a sheep, yeah. All right. Are y'all enjoying these songs? Yeah. Yes. You know, when God created the earth was void, without form. And that's what that is. And that's what y'all are going to be talking about tonight. We're going to be talking about this week about God's creation. All right. But I tell you what, who's got some joy? Who's joyful? You do? The joy. Where's it at? Where's your joy at? Is it down in your heart? Yeah. I got the joy, 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 joy down in my heart. Down in my heart. Down in my heart. I've got the joy, 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 joy down in my heart. Down in my heart to stay. I've got the peace that passes understanding down in my heart. Down in my heart. Down in my heart. I got the peace that passes understanding down in my heart. Down in my heart to stay. I've got the love of Jesus down in my heart. Down in my heart. Down in my heart. I've got the love of Jesus down in my heart. Down in my heart to stay. If the devil doesn't like it, he can sit on and attack. Ouch! Sit on and attack. Ouch! Sit on and attack. And if the devil doesn't like it, he can sit on and attack. Sit on and attack to stay. All right. You know, remember here several years back, we found this long lost verse of this song? It was up in your attic or something like that. You remember that? Y'all ready to sing that? Y'all ready to sing it? Here it goes. It goes like this. I've got the wonderful love of my precious Redeemer way down in the depths of my heart. You ready? I've got the wonderful love of my precious Redeemer way down in the depths of my heart. Way down in the depths of my heart. Way down in the depths of my heart. I've got the wonderful love of my precious Redeemer way down in the depths of my heart. Way down in the depths of my heart to stay. Woo! I need a an inhaler. All right. So, does Jesus love you? Yes. Does Jesus love me? Yes. You want to sing about that song? Yes. Jesus loves me, this I know, for the Bible tells me so. Little ones to him belong. They are weak, but he is strong. Yes, Jesus loves me. Yes, Jesus loves me. Yes, Jesus loves me. The Bible tells me so. Jesus loves me when I'm good, and I do the things I should. Jesus loves me when I'm bad, but it makes him very sad. Yes, Jesus loves me. Yes, Jesus loves me. Yes, Jesus loves me. The Bible tells me so. I love Jesus, does he know? Have I ever told him so? Jesus likes to hear me say that I love him every day. Yes, I love Jesus. Yes, I love Jesus. Yes, I love Jesus. In prayer I tell him so. Very good. We are going to sing one more song, and after this song we're going to be led in prayer. And we're going to be led in prayer by Brother Jonathan Stubblefield, and then we will go to class. All right? This next song is God is So Good. God is so good. God is so good. God is so good. He's so good to me. He loves me so. He loves me so. He loves me so. He's so good to me. He answers prayers. Where's your prayers? He answers prayers. Get 'em up. He answers prayers. He's so good to me. He watches me. He watches me. He watches me. He's so good to me. All right, let's all get our prayer hands and let's pray to God while Brother Jonathan leads us in the prayer.
Our God and Heavenly Father, we thank you very much for blessing us with the opportunity to gather here this evening. Thank you for blessing us with this opportunity to study your word. And thank you for blessing us with this occasion to gather and present this special series of lessons that are especially designed for our children. We pray that you continue to be with us and show us the wonders of your glorious creation. And in your Son's name we pray. Amen.
All song do we sing before we go to Bible class?
Mouse.
Tiptoe and whisper.
Mouse.
All right. Tiptoe, tiptoe in God's house. Tiptoe, tiptoe in God's house. Tiptoe, tiptoe in God's house. Be as quiet as a little mouse. Whisper, whisper in God's house. Whisper, whisper in God's house. Whisper, whisper in God's house. Be as quiet as a little mouse. Tiptoe, whisper in God's house. Tiptoe, whisper in God's house. Tiptoe, whisper in God's house. Be as quiet as a little mouse. All right. Nursery class? Tanya and Chrissy?
Where's Mama?
They just do it as a read.
Mama. Mama.
All right. 4-year-old in kindergarten? First and third? Four through six? All right. Teenage class. What's the size of the teenage class? All the adults, if we can slide over here, we're gonna have the podium over here for the class. Come on, everybody.
So I've got a PowerPoint for this evening. John, where is it? Oh. Okay. That's not what that should be. Let's see. You having technical difficulties? Okay. Can I hand this off to a computer expert and come back to the PowerPoint?
He is not here, but I'll see what I can do.
Okay. Well, good evening, everybody. I've been invited to do the first lesson for this evening, and I gotta say I've had a lot of fun making the lesson. I think most of y'all know who I am, but for those of you who don't, I'm Jonathan Stubblefield. We're going to be discussing today the first topic for this series of lessons: design demands a designer. Design demands a
as I understand it, it's an observation that for all the billions of miles of space that we can observe with our technology, we have yet to find any traces of intelligent extraterrestrial life. And how can that be?
So it's surprising we can't find aliens.
Yes.
Why would that be surprising?
Well, it's been more or less assumed by many people that because the universe is so big, there has to be statistically another planet capable of supporting life.
Exactly. In our galaxy alone, the estimate is about 100,000 intergalactic civilizations, or should I say interstellar or other intelligent civilizations, should be observed. If we take an estimate of about 1 million Earth-like planets, and we say that only some percentage of those actually develop intelligent species, then we should say, oh, there should be 100,000 or so intelligent species in the galaxy. But what do we see whenever we look with our SETI telescopes and we listen for the communications of these extraterrestrials, and whenever we look at the chemical compositions of their planets, their atmospheres, we don't see any signs of life whatsoever. We would expect to see radio transmissions. We would expect to see evidence of oxygen being produced in the atmosphere. Those are things we do not see. All right. So this is going to be an interactive class. I'm going to be calling on you all and things like that, and I hope you all will be open to answering questions. Let's talk about the proposed explanation for this Fermi paradox.
Can't hear you.
Great filters.
Can't hear you.
Can't hear.
You can't hear me with the microphone?
Make sure you clicked it on.
Oh, it turns on?
There we go. I work in artificial intelligence. That means I'm only artificially smart. Okay, great filters. This is a proposed explanation of the Fermi paradox. Now, who wants to talk to me about this that's heard of it? Nobody, okay. Well, the idea is that since we don't see a lot of aliens out there, there must be something really difficult in the natural history of the development of an intelligent species that is really hard, a big hurdle to overcome. Like not blowing itself up with nuclear weapons, like having a planet that's in the right habitable zone of the star, like actually starting out as a singular cellular life. This is the scientific perspective we're talking about. But these great filters gave me an idea. We can actually take this paradox and turn it around on its head. If we look at the galaxy and we see no signs of intelligent life out there, why should we look at the planet Earth and expect to see anything different? Are there any signs of life on Earth? What makes us special? Why would that happen? Why would that happen?
God created that way.
That would be our answer. But apart from that answer, it's really difficult to explain how we could have made it past the great filters.
Let me guess. Science says, well, it's physically, even though it's possible, we somehow managed to do it.
Yes, they do say stuff like that. They also say things like, well, obviously we developed in a planet that's habitable to observers who are capable of asking that question. This is known as the anthropic principle. This is also an example of circular logic. Don't let people trick you with this one. They'll say, we might say, well, the universe really does look like it's been designed, and they'll say, well, obviously it looks like it was designed because we're here and we were able to observe it. Don't fall for that circular logic. But let's talk about some of these great filters. There are several that they proposed as possible examples of great filters. What do y'all think, first of all? What do you think would be really, really hard to have happen by accident? Don't cheat by looking at the slides. Anything else? Something out of nothing would be difficult, but let's assume there's something there already.
Life with no life.
Life from no life. Intelligence out of a mutation.
Seasons.
Seasons. Okay? Yeah, seasons. What else would be hard?
Organic chemistry.
Organic chemistry. Awesome. These are all really difficult things to have happen, and they're proposed explanations why we don't see aliens. But let's look about whether we think this could happen by accident here on Earth. So, as we go through this
lesson tonight, we're going to be covering lots of philosophy as well. Keep in mind, just keep it as a bookmark, these are what's known as teleological arguments for the existence of God. Teleological as in design demands a designer argument. So these are some good things for you to have on hand and in your mind. So let's talk a little bit about the first great filter we're going to cover tonight. Okay? This is the first one. And so now we're starting to get into the actual meat of the lesson. Pretty much everything before that was introduction. The first great filter that a species such as ourselves would have to overcome would be finding a planet that's habitable for the formation of life. Now, this is actually kind of a hard thing. Now, what is required for life to exist on this planet? Water, oxygen, food, sunlight, carbon. What else? Temperature, atmosphere, gravity. Lots of things. Okay. Let's broaden this question a little bit. What's required for life to exist in our universe? The universe didn't have to be the way it is right now. There's a lot of things that could have been different. The laws of physics could have been different, right? Imagine if things didn't work like this, right? Or consider this. There's not just matter, there's also antimatter. Who's heard of antimatter, right? Everybody? Raise your hand if you've not heard of antimatter. Good. Okay. I don't want to have to explain that one. But one of the big problems that have troubled scientists is why there's any matter in the universe at all. Why was there not equal amounts of antimatter and matter created, and then they all disassembled each other? So all these things that we've mentioned, the presence of X amount of matter in the universe, the position of the Earth in the exact position. Yes, would you have a question?
Yes. Heard of antimatter, you're still gonna have to explain.
That's mean. Okay. All right. We'll get back to that. All these things are examples of what is called fine-tuning of the universe. When we talk about the Earth being the exact perfect Goldilocks position for life to be able to be formed, having water being of the right size for gravity, having a specific tilt so that it is able to have seasons, having a large moon to keep the planet stable, having Jupiter-sized planets to intercept incoming asteroids, having a universe where the ratio of the masses of the proton and the electron are just right so that DNA can be stable, having a universe where matter exists at all and wasn't all destroyed by antimatter, having a universe that is spatially flat. If you have too much energy in the universe, it starts to cave in on itself. Too little energy, it starts to expand out and rip itself apart. We're living in a pretty flat universe. All these things are examples of what are called fine-tuning. Now, here's the teleological argument of fine-tuning. Basically, we see that the universe has such and such parameters that are very special because they allow life to exist, right? And those parameters, if they happened by chance, would be very, 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 very small chance of them happening. So we think it's more likely that someone put them that way. Does that make sense as an argument? Okay. Does everyone follow that logic? Is anyone having trouble with that one? Okay. So let's review a little bit. What are some of those examples of fine-tuning? I want some people I haven't heard from to give me some of my examples back to me. If I don't have volunteers in the next few seconds, I'm going to have to start calling on people.
Position of the Earth.
The position of the Earth relative to the sun. Yes. What else?
You mentioned the fact that there are bigger planets to intercept asteroids.
Yes. Yes. What else?
Well, the tilt of the Earth is very important.
The tilt of the Earth is very important. What else?
We're shielded by the magnetic.
That Alan Belts.
Okay. Okay. What about not just the Earth?
The fact that the amount of oxygen itself in the air is such that the whole atmosphere doesn't ignite with a spark.
Okay. Now that's not one I've heard before, but okay. Anyone else? Want to go ahead and give me some of my examples back? I want to be sure we've got a good understanding of this one before we go on to the next one. Because we got a few of these to cover tonight. All right. Yes.
I'm not sure about this. I like to think about things before I say anything. But
Uh-huh.
I think I have read that no matter how hot the water on the earth becomes, we can find some living forms, very small maybe, but living forms even in the very hottest water. Now, how does this relate to fine tuning?
Archaebacteria, yes. I'm not sure that it does specifically, except that if the Earth were a little bit farther or closer away, you still probably would find it difficult for even those things to exist because of how hot or how cold it would be without the sun in the right spot.
Or if they do exist, what does that mean? And then also, I think I've read in places like Antarctica, we find living forms near the, well, there can even be hot places which have these forms. Maybe I have my facts wrong, of course, but then also that even in the cold, that we find living forms that we wouldn't think would be alive there.
Mm-hmm, mm-hmm. Now that's true. Life is very durable, but the range of temperatures that exist on the Earth are still pretty small, and in a cosmological sense. We start about getting closer to the sun. We're starting to talk about billions of kelvins. That would just be very unfeasible for life to exist at that point. So that Goldilocks zone where life could exist might be a little bit wider if we consider things like archaebacteria and these really resilient forms of life, but it's not going to be the whole width that it could be.
Don't those things suggest the possibility that on some of those planets that we're not able to observe as much as we think we can, that there may have been extreme forms of life? For example, we have such on the Earth. Maybe they have even more extreme forms of life. How would you reply to that?
Well, that's certainly possible, but I would have to reply to that the lack of evidence is not itself evidence. Because I wouldn't, if someone wanted to argue with me that way, that there's probably lots of life out there, I'd have to say, I'm sorry, but the burden is upon you to show me that there is, not to suggest that there could be. Yes?
Can we see it with a telescope? Can we see the changes that life produces in the atmosphere and stuff with a telescope?
We should be able to, unless, of course, it's one of those kinds that might be in a deep subthermal vent. We can't get that into the atmosphere, things like that.
And also, we need to remember we're talking about intelligent life capable of doing things.
Yes. Yes. When we talk about that estimate of about 100,000 or so intelligent civilizations in the galaxy, that is where the Fermi paradox itself comes from, and where we start to question, well, why are we here? What makes this place special? So, good thoughts, though. Very good thoughts. So, this is the argument from fine-tuning. This is an argument for the existence of God that states the universe appears to be designed with a very specific purpose, to be habitable to life, to be habitable to us being here. And those things we think are much more likely to have happened with an intelligent creator rather than by accident. And that's the short summary of this argument. Now, how does everyone feel about this? Are we ready to move on to the next one? Okay? All right. So let's talk about the second of these great filters.
I'd like to ask one more question.
Uh-huh.
And that is, when we say we do not pick up any radio communication,
Mhm.
what makes us think that's the only way that intelligent beings could communicate?
Well, we don't necessarily believe it's the only way that they could communicate, but it's what we can potentially observe from here.
Can we observe changes in the atmosphere?
Yes, we could also observe changes in the atmosphere. The astronomers actually are very creative and clever in the way they look at things. They can look at things through telescopes so powerful they can actually do something called atmospheric spectroscopy. Whenever you do atmospheric spectroscopy, you're talking about looking at a star's light through the lens of that planet's atmosphere, and you're able to say some things about the composition of elements in that atmosphere. So if we see a planet that has lots of oxygen in it, we'd have to be like, wow, that might be a sign that there's some plant life on that planet. Okay.
I think that in answer to Mr. Williams' question, you would have to have some kind of medium that would be capable of crossing space.
Mhm.
Sound would not cross space, so you couldn't communicate by sound that way.
Mhm.
Light would be difficult because of intervening interstellar dust and things like that. So communicating by visible light would be difficult. You would need something that would be able to penetrate those obstacles to overcome them. And there's limited things that can do that.
Mhm. Yes?
But didn't you say if the people that are looking for intelligent life, if they looked at our planet, that they could see that that's the case?
That they should be able to see that. I remember there was a very interesting headline that I saw one time. Scientists discover signs of life on Earth. And this was one of those atmospheric spectroscopy experiments that they did. They wanted to see what life would look like through their telescope, so they pointed their telescopes at Earth to actually see if they can detect the life that's here. And they were actually successful in doing that. As far as radio communications, I think there's some debate as far as how far the range is on that, but early in the process, I think that they still could see some things. That's why the entire SETI project exists, after all. Okay.
I got a question.
Uh-huh.
So when they were looking at Earth, they would be looking for things like oxygen and water, things like that,
Mhm.
to support our life.
Yes.
But what if the parameters for life were different for other intelligent beings? Perhaps they don't need oxygen. So when they're looking at these other planets and they see no oxygen available there, they may assume that it can't support intelligent life, but perhaps it can support our intelligent life.
Well, you see, whenever they're looking for oxygen, they're not looking for intelligent life. They're looking for plant life. Oxygen is the waste product of plants that we are able to breathe and then use for our own energetic purposes. So the oxygen wouldn't be a signal of intelligent life, but of plant life. Now, as far as other possibilities of life, there have been some studies of things like silicon-based life forms and some ideas behind that. But another example of fine-tuning here, the carbon atom itself is very perfect for life with its size, with its ability to form complex structures with itself. It has 4 different places it can bond, basically. So it's almost like a Lego. It's the Lego out of which life is built. And its nearest cousin, the silicon atom, just doesn't do it as well. So if we expect to see any other life out there, most likely we would see other carbon-based forms of life, is my understanding. Don't quote me too much on this one. You're getting a bit outside of what I've researched and prepared for this. But my understanding is that it'd be very hard to make life out of anything else but carbon. Okay. Any other questions? Okay.
Well, what would you say about angelic life?
Angelic life.
Yes.
I wouldn't necessarily have to, I wouldn't be able to call them life, honestly.
You don't think angels are alive?
Not in our sense of the word life. Life is defined as something that grows, reproduces.
Oh, well, okay, now. All right, go ahead.
You see, a lot of what we're looking at right now is from a very scientific and secular perspective. I think that's beneficial for this study. Because after all, whenever you go out and talk to your neighbors about why you believe the world is created, you're not necessarily going to have the Bible to back up with. I think I might discuss this later, but whenever Jesus spoke to the devil, whenever he was tempted and was able to answer just from Scripture, I'd say, don't do that. Because you're not talking to the devil. The devil believes in God and the Bible. A lot of the people that you meet are not going to. So you're going to have to come up with something else. So we're going to be looking at these, yes, Mr. Blackford.
Well, go ahead and develop your point. Then.
So we're going to be looking at this from a secular perspective a bit, evidence why we believe God exists, without necessarily relying on the Bible to just say, well, the Bible says so. Instead, we will say, we believe God exists for these reasons. We believe that he is the God of the Bible for these other reasons. Does that make sense? Mm-hmm.
You stated earlier that every means we have of trying to discover life in outer space, we haven't found anything.
Mm-hmm.
Why do you think there's such a desire to find it? What is the compelling reason that we'll spend billions and billions of dollars trying to find life in outer space, intelligent life, when everything we've tried hasn't found any?
I think there's an intense curiosity on some people. I can't really speak for the people that are doing these projects. I bet some of them are intensely curious. Some of them may just really believe that it's out there and want to confirm it. Some of them may be some of those scientists that said we should expect to see 100,000 alien civilizations. Why haven't we seen any of them? I'm not sure. But that's the best I know there.
I think some environmentalists may think that, we're using up this planet, so they want to find a place, some other place that human life could exist.
I think the point, perhaps, Mr. Black, that we're making, and we can comment again, but some people are looking because they don't want to believe in God.
That's the main reason.
That's quite possible too. Okay.
Yes, they want to prove that evolution has taken place. Naturalistic process has taken place to produce everything.
Mm-hmm.
And if they could find that somewhere else, it would help to bolster their cause. But they're really determined to find it, whether it's there or not.
Now that is a very good point that I want to bring up. How many times do scientists say evolution happened? Once. Once. How many times did life come from non-life? Once. How many times did one cell get inside of another cell and create the first eukaryotic cell? Once. I find that a little bit unbelievable personally, that things would happen exactly once. If things happen, they should happen multiple times. After all, what is science if not repeatable? And so, with that in mind, let's get to our second great filter. The first, macromolecules and biological information. So, the second great filter that we're going to discuss is the appearance of macromolecules at all. Organic chemistry actually happening. So if you remember from our discussion of great filters, an intelligent species or whatever in its natural history first has to find itself on a planet that can support life, and then from the secular view, it then has to somehow start forming some organic chemistry to create life from. Right? Right. So, this is another form of a design argument. It's called the argument of biological information. Now, let me give you all the gist of this argument because it's a little bit complicated. The gist of the argument is that life has a very specific structure in it. How can you tell if something is alive? Who can tell me that?
You poke it and it moves.
If it moves?
You poke it and it moves.
You poke it and it moves? I poked a rock the other day and it moved downhill. Is it alive?
Some live things you poke and they don't move.
Yeah?
Has to be breathing.
Has to be breathing. Has to be breathing.
That's animal matter, that's not plant.
If I had a big old bellows, is that breathing? It's exchanging air. Is it alive?
Would cellular division and growth be a big thing?
Bingo. So, life is defined as something that grows, reproduces, takes in matter from its surroundings and converts it to its own purposes. That's the kind of life that we're talking about. Now, for life to be structured this way, it typically is structured in cells. So you have a cellular membrane, and you have all these macromolecules inside that are all arranged in this very specific configuration. Now, really specific configurations are really hard to have happen by accident. So let's think about a deck of cards. Now, who wants to play poker with me? Raise your hand. I need one more person. Travis, you're playing poker. Okay, playing hypothetical poker. So let's suppose I have a deck of cards and I start dealing them out. And Courtney gets a queen, Taylor gets an ace, Travis gets a 3. And then I get a jack. Courtney gets a queen, Taylor gets a 2, Travis gets a 4, and I get another jack. Courtney gets a queen, Taylor gets a 3, Travis gets a 5, I get a jack. And then the last coin is Courtney gets a queen, Taylor gets a something else, and you get junk, and I get junk. Did I stack that deck?
Yes.
Yes? Why do you think I stacked that deck? Because she got all 4 queens. So what you're saying is that the deck looks designed, right? So whenever I have the deck in a specific order, that's very less likely to happen than by chance. And the reason is because there's many more ways for the deck to be disordered than it is to be very specifically ordered. Would you agree that that's possible? I could have 50 different ways that the deck could be shuffled and one way that it could be stacked, for example, right? Whenever we look at biological macromolecules, when we look at DNA and all the letters that are composing it, they look to be in a very specific order. They look to be in an order that codes for proteins that makes life possible, right? They don't look to be in a random order. And this is the argument of biological information. It says that this information could not have happened by accident. It's very, very, very unlikely for it to have happened by accident. And here we need to talk a little bit about entropy. Who's heard of entropy before? Entropy. Over here, entropy. What is entropy? That's a hard question. Okay. What's entropy?
Is it the natural decay of everything over time?
That's related to entropy, but it's not quite entropy. Entropy, there's 2 different definitions of entropy. If we're talking about thermodynamic entropy, we're talking about the amount of uselessness of the system to produce energy and do work. If we're talking about information entropy, we're talking about the amount of disorder in a particular system. And that disorder is supposed to increase over time for the entire universe or for a closed system. That's the second law of thermodynamics. Remember that our secular evolutionist friends will assert that this biological information, which is relatively low entropy because there's very few different ways that it can have the correct biological information to code for proteins and to conduct the functions of life, compared to the many, many, many more ways it could just be a random jumble of letters. They would assert that that happened by accident without any guiding force behind it, right? Isn't that what our evolutionist friends would assert? Yes. Doesn't that go a little bit against the second law of thermodynamics that says entropy tends to increase? Yes? Okay. That is essentially the argument of biological information. When we look at macromolecules and DNA and proteins and these things coming together, we don't see them coming together randomly. We see them coming together and doing a specific thing, being life, being the components of life. Thus, the deck looks stacked. It doesn't look shuffled. That's the argument of biological information. Now, let's discuss biological information a little bit.
I mean, it's like looking at a child and saying, go clean your room.
Yep.
Children don't tend to go just clean their room.
That's right.
Their rooms tend to just fall apart, and you have to tell them to clean their room.
Yep.
And the same way with, like, evolutionists are basically trying to say that, you know, matter itself, basically when it cleaned its room, it fixed itself. When the natural process of things is to fall apart and become chaotic.
Exactly right. So, this is a bit abstract, so let's be sure we understand it. I want someone to raise their hand and explain to me the argument of biological information in their own words. Or I'm going to pick on you. In 5, 4, 3, 2. You already explained it. One. Mr. Teddy, will you explain biological information for me? Brendan, will you explain biological information for me? Would someone like to explain biological information for me?
Well, I don't really understand where you're going with this, but it's been 50 years since I took thermodynamics on a little lesson. But
Okay.
there's only a certain amount of energy.
Mm-hmm.
It cannot be created; it can only be changed.
Okay.
So over time, energy will deteriorate if it's not corrected.
Uh-huh.
I don't know that's one.
Okay, you're getting close. Keep in mind, whenever we have life, when we have things like our DNA, like our proteins, all those individual letters that make up our DNA, that code for proteins, they could be in any order. They could be in random jumbled up orders. There's no reason why they couldn't be, but they're not. They code for specific proteins. They code for specific amino acids that go into a row that make the protein work, that carry out the functions of life. There are many, many, many more ways for them to be complete garbage than there are for them to be good functioning life macromolecules, right? So it's much more likely to find them in the form of garbage. And it is very unlikely that in the form of some primordial soup, they would just spontaneously assemble themselves into functioning macromolecules. Travis?
I think I understand what you're saying, but I have a question.
Yes.
I understand that you're saying that that the odds that they would be aligned in the specific order to produce life and to have all the functions that a person has is basically impossible. It's about as impossible, not impossible, but improbable as you shuffling a deck of cards and you getting all the queens. I mean,
It's quite a bit more because you can shuffle a deck of cards and get all the queens. It happens in poker tournaments.
Well, I have a question.
Yes.
You said that it's not likely. You said it's more likely that if this was random, that these all the DNA would be in a garbage order. They
Yes.
wouldn't produce anything.
Yes.
As opposed to what we have.
Yes.
And so the odds that it would happen are slim to none, therefore design. I think is your argument. But
Yes.
my question is, do we find them in garbage order? Do we find that ever? I mean, is that a thing that you do find in nature?
No, define garbage a little bit is a question.
However you define it, will.
However, I defined it a while ago. So I defined the garbage order as not coding for any proteins, not being a good biological macromolecule that has a function in a cell, right? This is a little bit tricky because there is what we call non-coding DNA that exists in our cells. The only thing is there's also really good coding DNA that codes for proteins. Now that non-coding DNA is not necessarily garbage. What it is not always clear. It might be a piece of DNA that codes for the scaffolding of the DNA that lets it be packaged up correctly. It might be DNA that has regulatory sequences that make you regulate how much protein you make. It might be ABG, ACG, 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 repeated over and over again. Oh, why it's there? Not sure. It might be some ancient viruses that got in there and have been jumping from place to place inside the DNA. It's not fully explained. But is it garbage? I'd have to say it might be an argument to say that some of it is, but to say that any of it isn't is a vanishingly small coincidence if it happened by chance. Yes?
I think of DNAs because I think of diseases, like mutations that cause diseases that don't allow people to live.
Mm-hmm. Mm-hmm. That's a really good point, and I think we may cover that a little bit later too. So, do we have a better understanding of the argument of biological information now?
May I make a comment on this question?
Yes. Yes.
Now, I think everybody, all schools agree that every generation has mutations taking place
Mm-hmm.
that are messing up that code a little bit at least, and that we are less capable in some way of, and they're almost all bad, not good, okay?
Mhm.
So let's say that 50 generations have passed. How much better off would those generations 50 years ago have been in being able to use their minds and their bodies to operate more ideally in a functional sort of way? What would all, and there's more and more mutations taking place all the time. How much difference? So we have less of this good code than we had. Is that true or not?
I don't know about that. It's a very good way that you're thinking, because you're recognizing that the tendency is for this good code to decay. Imagine if you had a piece of paper with some important document on it, and you copied it, and then you took the copy and you copied that, and then you took the copy and you copied that, and you did that all week. Are you going to have your original document at the end? No. Little errors are going to accumulate, and they're going to mess it up. The fact is that DNA appears to be designed to be very high fidelity at keeping its original code, to the point the cells have error checking mechanisms, to the point that cells will deactivate themselves and turn themselves off if the DNA gets damaged, so they can't spread the bad code, to the point that most mutations can be silent and not actually do anything, to the point that most mutations don't get passed on to the next generation if they don't occur in the right kind of cell. So I couldn't say that necessarily the humans of 50 generations ago were terribly different than us.
Now, I have read in the last few years from a few ex-atheists who have become theists. And one point they make out is that if the evolution of this is true, for how long the human race has existed, today most of us would be idiots. Is that true or not?
I think there are a lot of blah, blah, blah idiots out there. I think again, though, God has created a high fidelity copying system.
Yeah, but why it's been 5 million, we've been around 5 million years.
I really don't think we've been around that long.
Okay. That would show that the evolutionist is wrong. It needs time for these things to develop. Of course, this time is a meaningless time, because time changes nothing, really.
It really doesn't. If the time were longer, you would expect it to decay more. Right. Okay. So, I think we now understand the argument from biological information a bit better. Does everyone feel comfortable with this? Do we have questions about this one before we move on? Because we've still got 2 more teleological arguments to cover. All right. Next one, then. Next great filter. Abiogenesis and the appearance of design. What does abiogenesis mean? Does that word mean anything to anybody? Life from no life. A, not, bio, alive, genesis, creation. Life created from not life. Now, for those of you who have taken biology and learned that all life comes from cells, existing life, you know that this sounds a little bit wrong, right? Nevertheless, our evolutionist friends assert that abiogenesis happened. And they assert that it happened how many times? Once. I find that a little bit unbelievable. Excuse me. Their assertion is that, as we mentioned, in some primordial pool somewhere, some random confluence of organic molecules that have happened, occurred there for some reason, came together, formed a cell that could start replicating itself and thus be life. Their assertion is that life is an accident. Is life an accident? Does life come from non-life? And one of the arguments that we can look at, one of the teleological arguments we can look at based on this great filter would be the argument that life looks designed, it doesn't look accidental. Now, what do I mean whenever I say life looks designed? Who in here thinks life looks designed to them? Okay. Can anyone explain to me why they think it looks designed?
Well, like, for example, like we talked about earlier, all the things that have to be in place in a certain arrangement, and if any one of those things was changed even a little, none of it would work. So it looks like as a designer that way, and everything seems to have a purpose. We interact with each other, we interact with nature. They take our carbon dioxide, we take their oxygen. There's a coming together there. And
Okay.
So it looks like we all have
So,
purposes.
complex interconnected parts and a purpose. Okay, so that's your idea of what makes life look designed to you. Does anyone else have any other ideas?
It didn't just happen once.
It didn't just happen once. Okay, can you explain that a little bit more?
The complexity just continues in every human being. There's not a human being that's less complex. It's all, like you stack the deck,
life has replicated itself. Yes, yes. Yes, life appears to be a machine that self-replicates. Now, I want y'all to keep in mind this quote, okay? I believe I'm quoting this right from Mr. Richard Dawkins, one of our evolutionist friends. Whenever he talked about one of his books, he said that evolution, or should I say, biology is the study of things that give the appearance of being designed. And I wish I could remember who said this one, but I don't. Someone pointed out that there's lots of talk about the appearance of design. There's not a lot of talk of the appearance of natural selection. Right? There's something for everyone to keep in mind whenever we talk to our evolutionist friends. Yes?
And if that's true, then the process is a hypocrite. It's telling us what's not true according to the evolutionists.
Yes, yes. Yeah. You can't point to evidence contrary to your ideas and say it's evidence for your ideas. You can't point towards lack of evidence and say that it is evidence either. Right? Okay. So, let's talk a little bit about the watchmaker argument. This is a classic example. Let's suppose that you come across a beach and you're walking along the beach and you see a few different things along the beach. What are some things you could see on the beach? Tell me. Seashells, sand, crabs, water, seaweed, jellyfish, pocket watches. No? There's a pocket watch on my beach. On my beach, there's a pocket watch. How'd that pocket watch get there? Somebody dropped it. How did that pocket watch come into existence in the first place? Somebody made it. Why do you say that? The complex things have to be made by somebody? They do? Are you sure? You think so? I've seen some pretty complicated accidents that have happened. Like, you ever see a plane crash? That looks pretty complicated. Probably some explosions look pretty complicated too. Why does the pocket watch look complicated and designed?
There's a lot of moving pieces that have to connect together.
It has a lot of interdependent pieces, and it performs a specific function.
It's not a disaster, it works.
It's not a disaster. It works. It does a thing. Right, okay. Now, let's go back to something else we might find on the beach. Crabs. Do they look like they're designed or like an accident? Do they look like the random piles of sand or dunes on the beach, or do they look like the pocket watch? They look like the pocket watch. Why do they look like the pocket watch?
Specific purpose.
They have a specific purpose, and what was the other thing that Kyle said? They have a specific purpose and
There's lots of complicated parts with it.
lots of interdependent parts. What are some interdependent parts of the crab? What? Muscles, skeletal system, nervous system, all those cells that are in it. What's the purpose of the crab? Reproduce, to make more crab. For dinner. Exactly. So, this is the watchmaker argument. This is the argument that life looks designed. We say that it looks designed because life has lots of interdependent parts without which it would not function. And it appears to be designed for the purpose of reproducing itself. Whenever you go and eat a hamburger, you're taking existing material and making it into more you. Whenever your dog has a litter of puppies, the dog is a puppy factory. It's making more puppies. If you look up the term von Neumann machine, that means a machine designed to produce more copies of itself. Life is von Neumann machines in biological form. Now, some of our evolutionist friends might say, well, you don't know what design looks like apart from human design. How would you know what non-human design looks like?
May I make a comment about the watch thing?
Yes.
The difference, besides of course reproduction, the main difference between a watch and a crab is that we know that watches haven't always been made. We know they've been made. And this particular one was made too. We know that pretty well. But you go back so far, we don't have watches. We may have other kinds of ways of coming in time, but we don't have watches anymore. In the case of the crab, no matter how far we go back, we mean, we don't know when it first started, unless we're created by a designer like the watch was in recent history or memory.
I think that's a really good point. Okay. Now, some of our evolutionist friends might say, however, that you can have complicated things that aren't designed if you have lots of energy. Now, what's a problem with this? I think this is one of the objections they might make. It's something that you might hear from your evolutionist friends. I want you to be ready for an answer. How would you answer for this? Travis, suppose you're telling me, look at how the life appears to be designed. It's got lots of interconnected parts, and it's for a purpose. And I say, well, Travis, aren't you aware there's a giant nuclear reactor up in the sky providing tons of energy to the planet Earth, and complicated forms can arise under those conditions?
I would probably say that if there was a machine capable of doing that repetitively on its own, that would indicate design also.
Nuclear reactor?
Yeah.
The sun?
Yeah.
Okay, that's one answer. The sun looks designed too. What about you?
I would say that energy is needed, but you need information on how to use it.
Yes, you go back to the biological information theory, biological information argument. Yes?
Energy doesn't just stay organized, it's volatile.
Yes, energy doesn't create organization. Energy creates more disorder.
It takes the intelligent use of energy, right?
Yes, it takes the intelligent use of energy.
You gotta be able to harness whatever it is for that purpose.
Yes, can I set a watch factory on fire and make lots of pocket watches?
No.
Would I be providing energy?
Yes. Yeah.
Do I need more energy? Can I go put in a bunch of dynamite?
Yes.
I can do that. Would it make watches? No, it would make a mess.
To make things, you have to change energy.
Yes, you do. Energy is required, but you also require that information, which does not have a tendency to spontaneously generate itself, as we discussed earlier. So I think we've got a really good understanding of this filter now. Does anyone have any final questions on this one? Because we can't run out of time before we get to the last one.
I got just a quick question.
Yes,
It sounded like a while ago someone said that energy can't be created, it can only be altered.
that's true.
Okay, so if you're making an argument that says, well, we put enough energy in it, then we can have that, wouldn't an argument be that energy had to have started somewhere? Are you still back at creation then?
Yes, you are. You're just farther back. Yes. You're all the way back to the Big Bang, and probably to fine-tuning arguments at that point. Why the universe, you think it's created rather than just spontaneously appeared out of nowhere. Which we're not going to get into. All right, last great filter. Now we're done with abiogenesis. What about complex life? This is the last great filter we're going to discuss. It's not the last great filter that could possibly exist or has been theorized. But as for tonight, we're going to talk about the tug between the idea of life evolving and the idea of irreducible complexity. Now, whenever I say the words irreducible complexity, someone tell me what you think that means. Can't get any smaller and still function. Yes, exactly. So this is another teleological argument for the existence of God, for the idea that life must be designed, not created by accident. The idea is, evolution says that all these complex forms we see in life formed by successive simple alterations of simpler forms. But if we look at certain structures of life, we say that could not have been produced in that way, because if you take any part of it away, it stops working. Thus, it cannot be, and you can't be evolutional and have a non-functioning thing that doesn't work until a million years later, is basically the idea. Does that sound good to everybody? We understand that? Okay. The idea is evolution claims that the complex things we see in life, things like our eyes, like octopus tentacles, like bombardier beetles' explosive flamethrower glands, like bacterial flagellum, formed by successive alterations of simpler things. But you can't have any of these things have any part taken away from them for the last step without the whole thing not working. Right? We see that sometimes. Yes.
And I have never been able to read any evolution function better than it does now. So it gradually adds all these steps as though it itself were the creator. There's no way an evolutionist can talk about any of these things developing without speaking as though the creature itself is self-creating itself.
So they've assumed a creator.
Yeah. And it has that kind of program in it that it can do those things.
That's a little bit intellectually dishonest by the sound of things. Okay. All right. So the idea of irreducible complexity.
But the point is they cannot talk without really finally talking like that.
Okay. Mr. Blackford.
Well, as far as the evolution of life, they say it happened through mutations, but the overwhelming majority of mutations are negative in nature. They're not beneficial.
Okay. That's
So for just one beneficial mutation to take place, it takes a long time, and that's why you have to have billions of years for all that to happen.
yeah, and you know what? That actually just I got to go on a tangent with that. If evolution is true, why don't we see those beneficial mutations happening, specifically in life forms that have very quick reproductive cycles? For instance, fruit flies, which are experimented on genetically in labs all over the world. They breed them over and over and over and over again. I've never seen a super fruit fly. Right? I've never seen one. Has anyone heard of one? A fruit fly that can talk? I've not seen one. Similarly, they say abiogenesis happened.
If they have mutations, they can't reproduce.
Some of them can, but a lot of them have a lot of trouble, specifically if they have antennas growing out of their eyeballs. Or feet, I should say. Feet. Doesn't work very well. Similarly, they say that at some point abiogenesis happened once and didn't happen ever again. I'd be like, why is it not still happening? Why can't I have a sudden bacterial appearance in my glass of water? And similarly, they would say that at one point, one bacteria and another bacteria bited up and formed the first eukaryotic cell. And I'd say, why don't we see that happening more? Okay, that's the end of my tangent. It's another thing to think about. That's just a bonus for y'all today. So you're getting your money's worth. Which is good because this is free. So back to irreducible complexity. So we try to finish up in these last 5 minutes. Irreducible complexity. Can anyone think of an idea? Let's think about human-made things now. I want you to tell me a human-made thing that appears to be irreducibly complex to you. Yes, one of you. A car.
Yeah.
A piano. True. Any other ideas? What's irreducibly complex? A kite. A kite. Okay. What else? An airplane. What part of an airplane would you feel comfortable taking out and still expect it to fly? The seat. So it's not irreducibly complex, but can you? You will get to a point where it is. You can't take out the engine or the cockpit or the fuel or the wings, right?
A generator.
A generator, a power generator. I imagine those things are very complicated. I don't know how those things are built, so I can't give an example like the airplane. But a car, you can't take out the engine, the steering wheel, the tires, the carburetor, the battery, the crankshaft, the universal joint, the spark plug, the vacuum cleaner. I don't do cars. Yes. A thermometer.
Very simple.
It is very simple.
The old style, if you had the mercury, if you lose the mercury, you're not going to do it.
You're absolutely right. This is a really simple thing that's still irreducibly complex. You've got your tick marks, your numbers, your mercury, and your glass tube. You take out one of those things, it's not a thermometer anymore. Okay, now, let's be sure we keep in mind some examples of what's a biological system that's irreducibly complex. Yes?
Some of the early automobiles not having carburetor, just gas dripping down without a carburetor.
I have no idea. I don't car. I don't car. I imagine some of the earlier cars had tires. That's the best I've got for you. Sorry, you're no more than me.
Wouldn't water be irreducible? Because if you
take anything out of the complexity of water, you don't have water, right?
That's true, but water is still very simple, and water is something that can form spontaneously if you have hydrogen and oxygen present in the same place.
If you take either one of those out, it ain't there.
Say what?
If you take either one of those components out, it's not water anymore.
That's true. But remember, the point of irreducible complexity is saying that it couldn't have happened naturally.
Okay.
Water happens naturally.
I got you.
Okay.
Well, I know you asked for man-made, but we were talking about, like, I think about our biology.
That's okay. We're going on to the biological systems. So.
Yeah, I was just gonna say, so like, if you think about the evolution, how a human came from a simpler organism, we need a brain to pump our heart, we need blood vessels to carry the blood and oxygen, and so if you don't have one of those pieces, none of it's gonna work. So therefore, did it all evolve together at the same time, in one big leap, or did something come first, which we know it couldn't have came in a sequence like that?
Now, some of them might say that all evolved together-ish, like may have come from something that looked like a lizard that only had a 3-chambered heart, that has a simpler brain, etc. But if we look at specific structures like the human eye, how would you ever generate a human eye? You have to have those rods and cones. You have to have those specific cells configured into that exact way. You have to be able to make rhodopsin to capture a single photon and send it as a neurological impulse. That's one of those examples of something that's irreducibly complex. Look at this picture up here. Who knows what this picture is? It's a bacterial flagellum. Who knows what, okay, who's not familiar with bacterial flagellum? I know you see them every day. No, you don't. Exactly. A flagellum is a tiny whip-like tail that the bacteria uses to swim, right? That's a rotor. That's a biomechanical motor. You can't take any of those parts out and have it work properly. This would be another example of that irreducible biological complexity. And unfortunately, the bell doth toll for me, your fellow man, and our time is up. Do we have any final questions before the kids get in here and we have to sing again? Yes, we mentioned that. The beetle that has 2 different
right. Did y'all have a good time in class? Yes. What did you learn about it? Nothing. God's creation. I want to read a verse for you. Genesis chapter 1 and verse 1 and 2 says, "In the beginning God created the heavens and the earth. The earth was without form and void, and darkness was on the face of the deep. And the Spirit of God was hovering over the face of the waters." I'd like to thank the Stubblefields for creating this. And this is what this is representing. All right, this is void. This is representing the first day. And if you come back, each day this up here will change. All right, who's going to come back tomorrow night? Let me see a show of hands. Who's coming back tomorrow night? There's not very many adults coming back tomorrow night. We're going to have to work on that. All right, good. Who's plans on being here all week long through Thursday night? Excellent, excellent. All right. Our next song, we're going to sing just a couple of songs. That way we have time for the ones that did not partake of the Lord's Supper to partake of the Lord's Supper tonight. All right? Our next song. So, is anybody happy? Is it happy? There's not very many people happy. Who all's happy? What do you do when you're happy? What happens right in here when you're happy? What's that? You smile, right? You see some teeth. Are you happy? Are you smiling? It isn't any trouble just to S-M-I-L-E. It isn't any trouble just to S-M-I-L-E. Whenever you're in trouble, it will vanish like a bubble if you only take the trouble just to S-M-I-L-E. It isn't any trouble just to S-I-N-G sing. It isn't any trouble just to S-I-N-G sing. Whenever you're in trouble, it will vanish like a bubble if you only take the trouble just to S-I-N-G sing. It isn't any trouble just to P-R-A-Y pray. It isn't any trouble just to P-R-A-Y pray. Whenever you're in trouble, it will vanish like a bubble if you only take the trouble just to P-R-A-Y pray. It isn't any trouble just to smile and sing each day. It isn't any trouble just to pray your cares away. Whenever you're in trouble, it will vanish like a bubble if you only take the trouble just to smile and sing and pray. All right. So something happened here about a month ago that made me really happy. There was our first through third grade class was wanting to sing a song, but they could not remember the words to the song. What song was that?
Fuzzy was a
Fuzzy was a caterpillar. Who's got a caterpillar? Let's sing the caterpillars. Everybody. Adults included. Let's sing the caterpillars. You ready to sing a song? Who's ready to sing the song about Fuzzy? Fuzzy was a caterpillar. He wiggled up the tree. He wiggled once, he wiggled twice, he wiggled right at me. I put him in a little box. Don't go away, I said. And when I opened up the box, a butterfly instead. Oh, I could never make one, not even if I tried. But only God in heaven above can make a butterfly. All right, very good. We're going to be very quiet now while the gentlemen serve the Lord's Supper. All right?
thank all the visitors that we had with us tonight for coming to us, and we invite you back. We do have the Vacation Bible School, remember, going through Thursday night at 7 p.m. As of right now, are there any announcements that need to be made? Let's remember Sarah Stevens' mom, Joanna Williams. She has been diagnosed with cancer, so let's remember her. By Kyle Cassidy. And let's all stand, and then after we're led in dismissal prayer, and then we will sing the booster song. So let's all get our prayer hands. We did so good earlier with our prayer hands. Let's all get our prayer hands out, and let's bow our heads and pray to God.
Heavenly Father, we come before you tonight. We're so thankful for the start of a new week. We're so thankful that you love us, God, and you care enough about us to create us and to send your Son to die for us, even though we would sin. We're thankful for all the blessings we have, Lord. We're so thankful for the church here and the work it's trying to do. We're thankful for VBS this week. We're thankful for all the kids and those that are coming out to take time out of their day to come and study from your word. We ask that it will be a fruitful week, that you be glorified by this, and be honored by this. Learn more about you and your work this week, and take it and to teach those around us. We ask that you would save us with you here. It's in Christ's name we pray. Amen.
Booster, booster, be a booster. Don't